Okay, in this video we want to go through some example problems of both displacement and position and velocity, similar to the type of problems that are in the position and velocity online homework and the position versus time online homework that you have been working on in class today and that you will work on in class tomorrow. Here's a first displacement problem. Calculate the total displacement of a mouse walking along a ruler if it begins at a location of 5 centimeters and then does the following. Whenever you're dealing with position and displacement problems, I think it's very useful to draw out exactly what's happening. So I'm going to draw a little scale here. So we'll start making a scale. So I have a scale 0 to 20 in the positive direction. I'll actually add some negative direction in here just in case we need it in this problem. So we know our starting position is at 5 centimeters. First thing we're going to do is walk 12 centimeters. So we're going to end up at a position of 17. Then we're going to walk -8. So we're going to end up at a position of 9. And then we're going to walk to the location 7. So we're at 9. We're going to walk to the position 7. We want to find the total displacement. So total displacement is starting position and final position, and we always do displacement. So anytime you have change in, it's final minus initial. So the final position minus the initial position will give us the displacement. So in this case, our final position is 7. Our initial position is 5. So our displacement is a positive 2 centimeters. Now we actually in this case wouldn't have necessarily had to draw out all of this because since we're given the final displacement of 7 centimeters, we could have just subtracted 7 minus 5 and gotten the answer. But drawing these out generally is very helpful in most cases. Now let's look at a velocity problem. Find the average velocity in meters per second of a bicycler who starts 150 meters north of town and is 1,200 meters north of town after 30 minutes. I find it easiest to write out all of our information first. If you'll get in the habit of writing all the information in the problem first, I think you'll find that you'll be much better off at solving these problems. So we know our initial position is 150 meters north. Our final position is 1,200 meters north. Our time is 30 minutes, and we're trying to solve for our velocity, our average velocity. Now, next I'm going to write out the equation. Average velocity equals delta x over t. I want this in meters per second, so the first thing I need to do is convert 30 minutes into seconds. So 30 times 60 gives me 1,800 seconds. So my average velocity is going to be my final position minus my initial position divided by 1,800. So 1,200 minus 150, my average velocity is therefore 1,050 meters or 1,050 meters over 1,800 seconds, which comes out to an average velocity of 0.58 meters per second. So if you'll get in the habit writing out all your variables, writing out the equation you're using, and then showing all your work to solve the equation, I think you'll be much better off at solving problems, and I have a much better ability to give you credit for all the things that you do correctly. Okay, let's look at this next problem. A school bus takes 0.53 hours to reach the school from your house. If the average speed of the bus is 19 kilometers per hour, what is the displacement during the trip? Take a moment, press pause here in the video, and try to solve this yourself. Then press play again and see the way I answer it. So I'm going to start by writing out my variables. Time, 0.53 hours. This is where knowing the units that go along with every variable is so useful. If you know that hours is a time, we know that's a time variable. Speed, or velocity, average velocity, it doesn't have a direction, that's why it's referred to as speed, but it fits in the equation the same way. We're looking for displacement. So average velocity equals displacement over time. So we take the equation, velocity equals displacement over time, plug in our variables, 19 equals delta x over 0.53. Multiply both sides by 0.53. We get a displacement, in this case of kilometers, of 10.07 kilometers. Okay, let's look at another problem. A hiker is at the bottom of a canyon facing a canyon wall closest to her. She is 280.5 meters from the wall, and the sound of her voice travels at 340 meters per second at that location. How long after she shouts will she hear the echo? Be careful to consider why echoes happen. So take a moment, pause the video, solve this problem on your own, and then let's pick back up. Okay, let's write out what we know. We know in this case that she is 280.5 meters to the wall. We know that the average velocity of the sound, 340 meters per second, and we're looking for a time. Key thing to remember though is this, be careful why echoes happen. Think about the echo. We need to think in this problem about why an echo happens. So we have a person, they're 280.5 meters away from the wall. When an echo happens, the sound doesn't just travel to the wall, it bounces off the wall and comes back. So in actuality, the displacement that we're going to talk about, total displacement, that's distance that's traveled for the sound, 280.5 meters, and then it's going to come back 280.5 meters. So our total distance that this is going to travel is 561 meters. Velocity equals displacement over time. 340 meters per second equals 561 meters over t. We need to cross multiply. 340t equals 561. We get a time of 1.65 seconds. Okay, one last problem here. A cross-country runner runs at 6 meters per second for 2 kilometers and 7 meters per second for 1.2 kilometers. What is her average velocity? Pause the video for a second, try this problem on your own, then press play and see the way I answer it. When we look at this problem, there are two parts to this problem. 6 meters per second for 2 kilometers and 7 meters per second for 1.2 kilometers. Now the easy mistake to make here is to think about this as being an average of 6.5. It goes 6, it goes 7, add the two together, divide by 2, and you get 6.5. But the person travels at 6 for a significantly longer period of time than they travel at 7. So the average is actually going to be closer to 6 than it is to 7, meaning we're going to get an answer somewhat less than 6.5. Now remember that our equation that we're looking at, average velocity equals displacement over time. For each of these, we're going to need to solve for the time because we need to find out the total displacement of the runner. That's pretty easy, 3.2 kilometers. So this runner is going to run 3.2 kilometers. The question is, what time do they run for? And more importantly, what is their average velocity? So I'm going to take each one of these. 6, got to change kilometers to meters, equals 2,000 over t. And 7 equals 1,200 over t. Solve for t in each case. 6t equals 2,000. T equals 333.3 seconds. 7t equals 1,200 in this case. T equals 171.4 seconds. Add those times together. Total time that this person is running 504.7 seconds. We need this in meters. So to solve the problem, the average velocity will be 3,200 meters divided by the total time it took to run that 2,000 meters, 504 seconds. You get 6.34 meters per second. So this is probably the most complicated type of average velocity problem. You've got to remember the average velocity is the total displacement for the entire trip divided by the total time. When you get different velocities and you're given distances, you need to find the total displacement divided by the total time. So you've got to work through the equation multiple times.